Hello everyone, my name is Norman, and today we are going to do a little tutorial on Mixins, especially for Fabric, but this will also work on Forge, most likely. So, just to give you the broad setup, we are going to basically kind of follow the tutorial here on the Fabric Wiki, but we'll see that this tutorial here on the Fabric Wiki is really not complete, so I have created a whole bunch of examples myself that basically follow the Fabric tutorial. Hello Jasmine, welcome to the stream. And in here, I will basically go through everything that I have discovered myself that isn't really anywhere on the wiki or anywhere online, but it is very useful to know. Additionally, I'll also just go over the basic stuff as well, right? If you are on Fabric, then setting Mixins up is quite straightforward. Will be quite nice, and I'll show that in just a second because I am also on Fabric, so I'll just quickly go over that. But it's very trivial. You'll not have any issues, especially if you use the provided example mod that they give you with Fabric. If you are on Forge, you can also use Mixins, but it is a little bit more complicated because Mixins are not supported out of the box. Even still. There is this good tutorial on YouTube that I found for Minecraft version 1.16.5. I'll link that in the description on the YouTube video. Hi. And you can watch that, and that guy really explains quite well how to set everything up, which is nice. It's a little bit more complicated, but you'll get it going. And once you have Mixins set up, you can just follow this tutorial and everything will be the same, which is great. Hey Maria, welcome to the stream. Good to have you. So, who is this really for? Maybe that is a little thing that we should start with. Why would you even want to use Mixins? Well, there is a reason why I am here in this modding environment, which is the same environment as I am using for my Nominal of Lights mod. Basically, I just copied the mod and then I made the examples in here. In a Nominal of Lights mod, for if you didn't know, you can place a tile entity at any block, right? Not just a block entity, not just a furnace or a chest or whatever. You can just right click on any block like grass or dirt or stone and it will place a tile entity there that will give us light. Very nice, but Minecraft doesn't support this out of the box because Minecraft basically asks your block, hey, Mr. Block, do you have a block entity? Yes or no? And then the block is hard-coded to say yes or no. If the block says no, then there's nothing you can really do in vanilla Minecraft. You just cannot place a block entity there. Too bad. So I had to change a bunch of things here with these Mixins. Basically what you do is you go into already existing code and you add things or you modify things in there. And in that way you can change how vanilla Minecraft behaves, and that is quite useful for things like this. Little disclaimer, if there are certain ways that you can do whatever you want to do in a way that does not require Mixins, like through events or callbacks or registries in Fabric or Forge, whatever you're using, then do use that because that is more compatible with other mods. What you can run into with Mixins is that you run into collisions, compatibility issues with other mods, and then it will be a little harder for like modpack creators and stuff to work with your mod. And you of course want as many people as possible to play with your mod, right? So do keep that in mind. I'll touch on that a little bit more later in this tutorial as well. Okay. So, if you are on Fabric, if you are on Forge, link down below, if you're on Fabric, then you will start off with this fabric.mod.json. And in this fabric.mod.json, you just specify everything in here about your mod, right? So the name of your mod, the ID of your mod, and then like your license, the icon, and then you have your entry points, and then you have your Mixins. Okay, this one is important. So a Mixin specifies a list with Mixin JSONs. Really, this is only just one value. You probably don't want more. But this will just be a JSON file that specifies all of the Mixins that you're using. So the example mod already specifies, basically example mod.mixins.json. Just change the name probably. You probably don't want example mod in there. And then your Mixins JSON should look something like this. Should be right next to the fabric mod.json, right in your file architecture. And in this nominal of lights.mixins.json, you have to specify a couple of things. Again, the example mod is your friend. Just copy everything and change everything out with whatever you need. So you can set your compatibility level. You can set your package where you put all of your mixins in. For me, that is com.no_studios.no_lights.mixins, which is right, or .mixin, which is right here, right? Java, and then com.no_studios.no_lights, mixin. That's where all of my mixins are located. And then you specify the file names without the .java or anything after that. So for us, for our example, we will be using the player mixin, which is right here, player mixin. Not quite sure why this turned into an abstract class. It's fine though. If you are working with mixins, I do recommend that you use IntelliJ. And it's completely free, or at least the community edition is free. Please use IntelliJ and not Eclipse. And I will show you why. Because, we'll get into this a little bit more later. If you inject a bit of code into the original Minecraft code, you have to specify the exact method. And that's not just drop item, right? We'll be overriding the drop item method in the player class. We'll get to that later. You have to specify this exact string. If you do anything different, like I remove this L, it will get an error and it will not work. If you are on Eclipse or any other IDE, you're going to have to exactly write this string yourself. That might be a bit difficult. It's somewhat straightforward, but it's laborious to say the least. So it's like the drop item, which is then the method, and then you have L, which stands for, I don't even know what it stands for, but you have to specify it every single time before you write a path. Then net Minecraft item stack, which is then the first parameter. Then Z is a Boolean, stands for Boolean, or for the second parameter. Then another Boolean for the third parameter. And then you have to again specify what it returns, which will be then a net Minecraft entity item entity. And that is your entire string. A lot of work, but if you have IntelliJ, you can just do drop item here. It just suggests that you click on it and boom, it's there. Lifesaver, absolutely. This will save you so much time. Please use IntelliJ. Okay, with that being said, let's actually get into this stuff. Today, we will be using the player entity class, right? And specifically, we will be using the drop item method in the player entity class. So drop item gets invoked every single time you press Q on your keyboard by default. Of course, you can remap it, but yeah, if you spit out an item from your inventory, this method will get invoked. And basically what it does by default is, if we just go through here real quick, it gives you an item stack, a throw randomly, boolean, and a retain ownership. The throw randomly is usually false. If you drop it yourself, it's false. I believe if you like die, throw randomly is true, if it just spits out of your inventory all randomly. Retain ownership is usually true, because usually if you drop an item on the ground, it has like a little cooldown before you can pick it up again. That is the retain ownership thing. If it's false, you can pick it up right away. If it's true, you have to have this little cooldown. Okay, and then the stack, of course, is the item stack that you're dropping onto the ground. Great. Now, if it's empty, of course, you do nothing. Well, whatever, you can swing your hand, doesn't really matter that much. What really happens here is, if it's not thrown randomly, so if you actually Q, spit it out, it will basically get the height of your eye. I'll actually do that here. It will spawn a new item entity at that height, at your position in this world with this current item stack. Then it will set the velocity to this whole math thing, which is basically just forward, right? It just checks whatever way you're looking, and then it does some sines and some cosines, and it just spits it forward. Simple enough. We've all played Minecraft. And then it returns this item entity. That's all that it does. Now, let's say we want to make some changes to this. A reasonable request. So what we do is we have to go into our mixins.json, and we have to create this new file here, player mixin. Then in our player mixin class, we have to specify at mixin player entity.class. So basically the class that we want to mix stuff into. Also simple enough. Sometimes it will just put an abstract there. I don't know exactly why. Yeah, it really does want me to put an abstract in here. Sure. Sometimes it just says, oh wait, I know why. I know why. We'll get to why this is necessary later, actually. This is all the way at the bottom of the example, so let's ease into this. Normally speaking, you can just do public class and then your class. You don't need the abstract. And then the player entity.class. Okay, then Maybe we want to just inject some code. Maybe whenever we spit anything out, we just want to do something ourselves. Let's say our mod needs to keep track of how many items the player has spit out of their inventory. Well, that means that every time that a player spits anything out, you need to kind of get in there, get a hook in there, and then say, well, whenever this happens, notify me, and then I can do some counting, right? If you want to do that, you can inject some code, add inject, inside the method that you want to target. So it's drop item, and then all of this, of course, this is our drop item method. Then add, which is the position inside of this method, we specify here at the head. So that means all the way here at the top before it does anything. So before this if statement, it will call this code. And then cancelable equals true. Is not really necessary right now. We'll get to what cancelable does exactly in just a second. I'm not entirely sure why I set cancelable to true here. Fine enough. It will work without this line. There we go. Okay, then we have to specify a method that kind of sort of mimics whatever we have here. So it sort of has to mimic drop item in that it should take in the same parameters as drop item. Right? These are the parameters that you're given inside of your method, so you might as well use those in your own method. Of course, it returns void because it's just like a little snippet of code that is pasted in there. It doesn't really return anything, doesn't really make sense to return anything because the vanilla Minecraft code doesn't do anything with your code, so really can't use that. And then it has this callback info returnable. And this callback info returnable basically says, well, if I put something in this callback info returnable, then return that thing. And of course, this is an item entity, so I can just give this returnable a new entity. And that will be equivalent to just putting a return statement right before this if. Just saying, return some new item entity. Probably not all you want. We'll get to that in a second, however. Then maybe we want to call some methods that are inside of player. Normally, if you're actually programming player, you can access anything in that class, right? So we would kind of want to use that ourselves. We have to do a little bit of work for this. So we can get this, which is the player mixin class, and we can cast that to an object and then cast that to a player entity. This will compile. Once it compiles, it will drop this code off in the player entity class, and therefore this works because this is in fact a player entity, and therefore I can cast that to a player entity and then that will work, and I can access player entity. Nice. Well, let's actually check this out, because then of course here I get the logger and I just output the display name as a string. So let's see if this works. We can save, we can compile. Again, I'm recording and streaming at the same time. So when compiling and running Minecraft, we might get a little bit jittery, but when Minecraft is actually running, we should be okay. And then also there's like this hierarchy, right? Oh, we are jittery right now. But injecting something in the head of the method before anything happens and then not using this returnable, so not actually returning there, just letting the method run normally for the rest, is your safest bet. That is the least impactful. It will always run. It just kind of sits at the top, doesn't really do anything. It's quite innocent. So usually that should still work. I have a bunch of eggs in my inventory. Let's get some diamonds. Let's go to full screen. There we go. Wait, actually we can't go into full screen because we need to pay attention to the logger here at the bottom of the screen. So pay attention to this logger here right next to me. So if I queue an item, I should see the name of my player inside of the log. And there we go. None of lights, which is of course my logger that says player 568. And I can't actually see that right now, but of course we're in a dev environment, so we get like a random player name, which is player 568. Pretty nice. I can just throw items around and you will see that I get more of these names logged to the console. That's exactly what we did here, so that is nice, that actually works. So we plugged it into the top of the method and it does its thing. Okay, let's get rid of you. Let's go to the next example. So now let's say that we actually do want to return something. Let's say, okay, we have this cool drop item method, but you know what, F it, it's stinky, I don't want to use it, I want to write my own. What you could do is you could inject, add the method, drop item. at the head of that method, so all the way at the top here, before the if statement, but of course after the first curly brace. And then I need to set cancelable to true, because I need to cancel this method, or I need to cancel running this method, right? Because I want to return early. That's very important, otherwise it will not work. Then, of course, I take in my item stack, my autonomy, my retain ownership, which is of course just my normal parameters, and then this callback info returnable. By the way, I can just add more things here, like a boolean a, and that of course doesn't compile. Because it doesn't know where to pull this a from, right? It has to be like this this signature. If I actually add that boolean a, and if I have the wrong signature, I can just hover over, at least in IntelliJ. I can click here and then fix parameters, and it does not work because it tries to, okay. Let's remove this boolean, then it will also not work. Then I can fix parameters and then we'll add it. If you have too many parameters, it's probably safe to just remove every single one. And then here, fix parameters, and it will put everything back that you need. Quite useful, but again, not sure if this is on Eclipse. I do know that this autocomplete is not on Eclipse, so be warned. Okay, now we want to just return something right away, right? We want to write our own little method here, and then return whatever we create. So we should get our player object, that is fine, right? Our this ourselves. Then here we can check if our current return value already is set. This will be useful later. Of course, if we inject all the way at the head, nothing is returned yet. So, right, in get return value, nothing there. So this should return true. This doesn't equal to null. That should return false because it is equal to null, right? So this should return false every single time. Then for our own code, we are going to just get the player I height, which is the normal height, and then we're just going to spawn the item entity at the exact same position, but we're not going to give it any velocity, so it'll just spawn right where it spawns normally and just drop down. Just there we go. And then we set the return value to item entity, and this will just call return this thing, and the method will just stop. Nothing else happens, and you will see that if we run this code, the item actually will not have any velocity, and it will just drop down, because this is all that it does. No set velocity is ever called. Is this useful? Of course not, but it's just an example. And so, if you want to do something useful, you can probably come up with something, right? That's why we are actually using the Nolan of Lights mod here as an example project, because of course I had a pretty good reason to use these mixins. Okay, but those are probably like pretty complicated. That's why we're using examples. All right, so we are here in our world in any second now, and then I can F5, look at ourselves, and then I can Q, and there you go. Q. And it instantly drops it back into my inventory, but you can see it here for a second, right? Like it spawns there, and then it gets picked up. Boop, 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 boop. No velocity at all. Nice, and we also get false like all the time. Okay, great. Exactly what we expected to happen. That's you can just uninject these, just comment out the inject part here, and then it will just not do anything. It will not get injected, and so you don't have to comment out the entire method. Quite useful. Okay. There are multiple places where you can inject code, of course. You can also inject into the tail of the method, and the tail, as you might expect, is all the way here to bottom. All the way here to bottom. But tail also gets called when return is already called. So it will call return item entity, and then it will still run your code. But it will put this already returned value inside of the callback info returnable. And so you will see that the callback info returnable, the get return value, is in fact not null. Most of the times it is already, or at least for this method, it should always be already an item entity. Sometimes with this velocity, sometimes with that velocity, doesn't really matter. So we should return, or we should see this one return true. Also, of course, we have our regular method definition here. We specify that we want to place it at tail, and then we can add locals here. Just need to import this. Sometimes it automatically removes unused imports. There we go. Cancelable true is still very important. So what happens here is you can see, well, in the parameters, I also have this double D in item entity. That is weird. Well, if we go here all the way to the tail, you can see that whatever happens, well, I suppose a stack is empty doesn't happen, but most of the times what happens is double D is this thing, right? And item entity is this thing. So these are locals, local variables that already exists before this return is called. And therefore, I can capture them, locals equals local capture fill hard, in here, just in my own parameters. So I can use these, which is really quite nice. You don't always need this. And if you don't need them, please do not use this. This can be very finicky. If I use this code, but when I run Minecraft and for some reason I run into this scenario where return null here is called because my stack is empty, then I will have a big problem. That will probably crash my game. Because of course there is no D and there is no item entity, so it cannot possibly feed that to my drop item method, which is injected at the tail. So be careful with this. With these local capture. If you don't need them, don't use them, but sometimes it is useful. In this case, it totally isn't useful. So, but you might come up with a way that it is. This is something that is not explained on the Fabric Wiki, by the way. So yeah, these locals, quite interesting, that you can use those. Okay. Do keep in mind that some locals you can't capture, like the F and G here. I don't think we can actually capture these. I can of course check float F. Yeah, it doesn't like that. Like there is a possibility that if I do float F, float G, it will still compile. It is really weird sometimes. I can try it because of course F and G are here defined together with D and item entity in the same scope. No, that doesn't work. So yeah, it's sometimes a bit of trial and error. The problem here probably is that F and G aren't actually don't actually get a value right away. They only get a value in like a local scope. That is probably why it doesn't work. And these local scope variables, well, they go out of scope before the return is called, and therefore they do no longer exist when the return is called, and therefore you cannot capture them. Oh, that makes sense. If you have some programming experience in a C-like language, you'll understand that. Otherwise, don't worry about it. It will tell you when you cannot capture a variable. Okay, so then we are going to get the return value. This should then return true. Then we can say item entity, which is the item entity that we have captured here. We can set the velocity. Then we can set the return value to, well, we just get the return value. This is completely useless. Don't really know. Oh, wait, it isn't useless. So the funny part here is that this item entity is the same thing as the return value, because we return the item entity, which is the same item entity that we capture with our capture. So if we set the velocity here to 0 with our capture, and then we just return get return value, well, that is the same item entity that we just changed to here. So this will return an item entity with 0 velocity at the beginning. So it should again just drop down and it should return true. Right, I hope that makes any sense. But I am trying to give a little bit more of an in-depth tutorial here, because if you come for like the very basics, you can just read this, right? It's fabricmc.net wiki tutorial mix and examples. It's the best guide out there, to be completely honest. And it's not complete, so yeah. Okay, let's load this bad boy up, and then we can test this. Here we are, F5, F5. We are Steve this time, awesome. Okay, so if we do Q, yeah, it instantly drops down again. You can see that this time we don't pick it up right away. Well, why is that? That did happen last time. Well, that is because now we call this at the tail. Oh, by the way, it also said true all this time, right? So it did actually have this return value. Otherwise, this would have been null, and we'd get like a null pointer exception here. All sorts of fun stuff. Anyway, worked as expected. If we go to the player entity class and we go to the tail here, you'll see that in item entity, this has already been set, right? It's already created an item entity with a pickup delay for us, and the set thrower is already set. Which is us, So that is why there is a pickup delay now, while that didn't happen beforehand, because that code was never run. Okay. We have a lot of stuff to get through. Oh yeah, I need to speed up a little bit. Half an hour for 2 examples. Okay, yeah. Let's get going here. All right, so we can also inject into the return statement itself. So then we inject writes at here and here. So there we go. It's different from tail because tail only goes right at the last return statement, I do believe. But return is injected at every return statement. Of course, that means that the callback info returnable should always have a return value because we explicitly inject it at return. Therefore, we can also set our item entity, which is from get return value. This is why we can just get our item entity from the return value and then change it. We do have like a not null check here, but it will always not be null. Actually, not true. Wait, hold up. It can be null. It can be null. If item stack is empty, it will be null. So we need to have, I don't know why that, so we need to have this item entity doesn't equal null here, just to check for that special case. And then we can set the velocity again back to 0. And that will work just like it worked before. You notice that I don't have any captures here. That makes sense because now I inserted at both return values. We inserted here and we inserted here. Therefore, double D and item entity are not defined at this first return, therefore we cannot capture those. If there was a capture before both of these, or a capturable variable before both of these, we should be able to capture that, but alas, no such example today. This is really quite a nice, like the drop item is quite a nice method to test all of this stuff with. It has a lot of properties, but not everything, unfortunately. Okay, hey, we're Alex again. Okay, so now you'll see that we do the exact same thing. And you see that, of course, because we only interject at the return statement, all of this item pickup delay stuff has already been set, which is like 2 seconds, I believe, like 40 ticks, 2 seconds. That's quite nice. Okay, then we can also have a targeted injection at an invoke. Now this is where things get really interesting. So you can mess around a little bit with the return values. You can mess around a little bit with like callbacks and interjection events. Very cool. But what if you really want to get into the grimy stuff? Well, this is where it all starts. We can go into our drop item, then we can interject or inject our code at the invocation of another method. And this time we select the setVelocity method. You can see that this is this method. So once setVelocity is invoked, we interject. And this page here on Fabric has a great visual little indication of what happens here. The point before a method call, after a method call, what are we doing? This is before a method call, right? So we're doing this one. So we are interjected before do something. So here we have something that do something, and before this line is called, we interject and we have a little bit of code. And this little bit of code just takes in, let's see, just a good callback info. So nothing too special. We can check that in here. Right, so this is very targeted. You can now exactly say, within this method, you can exactly say where you want to inject your code. So not just at the end or at the very beginning or a return call, but in any of these lines that calls a method. And I believe that a constructor is also a method that you can use. Also set pickup delay, set thrower, set velocity, next float. You can interject at any of these, and you can do it before or after. By default, it's before. We'll check out how to do it, how to inject after a method call. Now we inject at set velocity, so we will just take in our normal parameters, right? Stack, throw only, random ownership, retain ownership, and then the callback info. Then we also have our captures, double D and item entity. Of course, because we capture here. We have set here ordinal equals 1, which means that we do the second, that we take the second version of this method. I can set ordinal 0, which will be the first version of this method. You can see that inside of drop item there are 2 set velocities. So if I set ordinal to 0, I will inject here at the line between G and set velocity. And if I set ordinal to 1, I will interject between L and set velocity. So that is what ordinal is for. It can be quite nice. If you don't specify ordinal, I'm not entirely sure if you plug it into both. I think it then gets plugged into both, actually. If I set ordinal equals 1, however, I might be able to capture a couple more variables here. Can I get float h or float f? I totally can. Float f, float g, float h. I can capture all of these too, because now I interject between L and set velocity, and therefore H, I, J, K, and L are all defined, so I can capture all of those. Pretty useful, something that I wasn't able to do with tail and head, so that is pretty awesome. If I now remove ordinal, yes, so then I can interject into both, which means that, well, F, G, and H are not defined at both versions of set velocity, therefore I cannot capture them. Makes sense, right? Then what I actually do in this method, just to check that it actually works, is I just check if there is a return value. It shouldn't have a return value yet, right? Because set velocity is called here before we return, so that should be false. And then we just set the velocity again to 0 and then return. But you'll notice that if we do this before set velocity, if we set the velocity to 0 before we then call set velocity to whatever it is, that really doesn't do anything. So we'll see that we get this logger output, so we'll see that it does actually work, but we will get a normal spitting motion. That is what we should see. Let's check that out. We will check out next up how to invoke or how to interject after a method call. And then we can do the exact same thing, but then if we set the velocity to 0 after we set the velocity to something else, then the velocity will actually be 0. That makes sense, right? So it definitely matters if you interject your code before or after a certain method call. So we can now go here into Alex and then we queue, and it is definitely doesn't do anything. Great. Oh, we set the return value here to item entity, which means that, yes, after L, we call this method and then we just return. So item.setVelocity, this line is never called. It's just never called. Here I can show you by just removing the return. Now we just change the velocity of our item entity and we do not return. Then you'll find that it really doesn't do anything. But we will get a false printed out. It's good to test these things. Also good to read your own code well. Doesn't always happen. If you're concerned about this crash here, it's just a invalid credentials exception. This happens every single time if you log into a dev environment. Don't worry about it. It basically means that I do not have a Mojang account. I do have a Mojang account, by the way, which is now a Microsoft account, of course. But I'm not logged into one because I'm in a dev environment. Then it will kind of crash, but also not really. Okay, so this should just do the normal thing. Yeah, there we go. And you can see false here in the console, so it does actually get called. Okay. Next up, we can inject again, but this time after shift equals at.shift.after the method call of setVelocity. Also ordinal 1, so we are only doing this setVelocity and not the first one, only the second one. And then we can local capture, and that means that we can actually get a float f and a float g. I'll just put those in here just to make it very clear that we are in fact using this last setVelocity. Then we're doing the exact same thing, but instead now we're just printing drop item 5. I don't need to know if get return value is true or false anymore. I think we got the idea there. And then we just set the velocity. We don't even need this return value anymore because we call it after this last line. We call it after set velocity. We set the velocity again, but to 0. And after that, just the return is called naturally. So it really doesn't make any sense for us to return here. So then we better not. This allows for other mods to interject after your code, and then their code still gets run. If you return forcibly here, which I did foolishly, then someone else's code, which might be completely unrelated to yours, but still important for their mod, might just not get run anymore. So please try to leave the original method intact as much as possible, just for that compatibility. Okay, let's see how this works here. So this too should, just like every other time, this just drop down. Boop, 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 boop. There we go. Drop item 5 is also called, so we know that this is actually called at the point where we wanted to get called. Right after. If this had been 4, just like we tried here, then if we interjected before, just like we tried here, then it wouldn't have worked. Or we just check that out. Okay. Then, oh, we have slices. Oh, yuck. Okay, well, I'll try to explain this as best as I can. I will need the visual aid here of the fabric tutorial. I don't know why you would want to use slices. Let me just put it that way. I'll go over it very quickly. I don't even think I'm really going to run Minecraft for this. I don't see the use in this. So what you're doing is, again, you're going to inject some code in your method, which in this tutorial is foo. It's a really dumb example because foo is just some method that takes in no parameters and then returns nothing. It's a little bit too trivial for my liking. It also has no captures or anything like that. It's a little bit too simple. Then we're going to target some invoke, right? So some method call. That is where we want to interject, but then also we're going to define a slice around this method call wherein we can interject somewhere, basically. And that will be do something 2 and do something 3. So from do something 2 to do something 3, we can interject our code. So this will do something 1. That's not this will do something 2. Do something 2 has not been called yet, so it will not inject here because it's outside of the slice. Then we have this will do something. Great. Then we have this will do something 2, which will be the beginning of the slice. Then we have this will do something. Because we don't specify any shifts, we'll interject it beforehand. Then we have this will do something 3. And then we will go out of scope again, because this will do something 3 is like the upper bound. And then we have to this will do something again, which will then not see anything, and this will do something 4. So in principle, if you have some methods wherein some other method is called very, very often, and you want to change that method, but only for some of the invocations, but not all of them, and all of these invocations need to be sequential, in that niche case, you could use slice, basically. So let's say, I'll paint this real quick, because I cannot believe how niche this really is. So let's say that you have some form of a method. We'll just call it foo for now, right? Let's say you have some method, and inside of this method, some bar method is called like a bajillion times. And then bar is called again, and then bar is called again. And now let's say you want to change some of these bars, or you want to inject some code after a bar call, but only sometimes and only between some sequential, in some sequential area. Let's say we have like a bar 2 defined here, and a bar 3 defined here. Now let's say we want to only inject code, wait, this before, right? Here, here, and here. Then we can, but not here and not there, right? Not in these places, and also not there. Then we can use slice, and we can just basically use bar 2 as an upper bound and use bar 3 as a lower bound, and then any bar call in this slice, that will get affected by our inject code. It's ridiculously niche. No idea why or in what situation you would use this. Worst case scenario, you just define some injection like 2 or 3 times. And then in all of those, you just kind of redirect to another method that you've just written statically. So let's say, just write like some static void A here. I don't know why that injected void there. then I can just write a bunch of these drop item 6s, and then I can just instantly call A, and then it will be okay. Why can I not just call A? Thank you. And that will just work. I mean, fine. Yeah, so slice, really weird. Not very useful. Maybe it's useful for you, you know? Maybe it's useful for you. Good for you. Not useful for me, though. Not really gonna show this off. This does the exact same thing, of course. I just put it in between like this method and that method, I think. And the return. Something like that. Anyway. Cancelled injection. Yes, now we can get to some more cancellation. We can also just cancel something altogether. Let's say that we have our drop item method, and then at the head, which is all the way at the top, right? We just say drop item 7, and then we just cancel the whole thing. We don't set a return value, we just cancel. That's it. Which means that whatever is already in callback info returnable will just be returned at that very moment. Of course, when we are all the way here before this if statement, nothing is being returned yet, so that is just null. And therefore just cancelling will just return null on the spot. And it will always do that regardless of what happens. So what will happen in a Minecraft code? Well, Minecraft will just get a null return. You can see that it handles this. It's explicitly at nullable. And it explicitly returns null when the stack is empty. So that means that it will just not spawn an item. So we can just queue and our diamonds will disappear and it will just not spawn any items into the world. Basically what happens. It's very evil. It's very evil. You could even say something like if item stack.item double equals item, then sur.cancel. So whenever you queue diamonds into the world, it will just eat your diamonds. You could be very evil with this. Yeah, so I can just F5 just so you see that it doesn't just drop back into my inventory. Here we go. Q, nothing spawns. It's gone. Absolutely gone. And so we can even do this conditionally. And I guess I should write that out real quick because it's actually a kind of a funny idea. Stack.getItem double equals items.diamond. It's capitalized. It's kind of dumb. .diamond. Then cancel, otherwise don't. So if I run this and I queue my items into the world, they disappear. If I do this with like eggs or something else, it will just run normally. It will just spawn the item like it normally would in vanilla. So we'll see this here in a second. So we are now inside of the world. I can get some planks, and if I spit out planks, it will just spit out like normally, right? Nothing weird here. If I spit out diamonds though, wow, that's so weird. The server is very buggy today. It's very laggy today, huh? Diamonds are gone forever. Well, there you go. I'll get a new stack here. Now we can get to redirection, and I'll show you visually what that really means. Injecting and cancelling. Yeah, so I follow the same structure as the tutorial here, but of course it's a little bit different. Like I actually put like an if statement in here and all of that. All very, very important things to know about. Anyway, so we can also inject code and cancelling a return value. Wait, that is something that we already did. Never mind. Modifying a return value, already did that. Redirecting a method call. Yes, so this is where the redirects come in. So what we can do is in foo, there is this method being called that is do something, right? But really int I equals something to do something, then it returns something that we don't really like. We want int I to be something different than what it returns normally. So what we can do is we can inject at this line basically with a redirect. So we can say, well, in method foo, then we can go to the invoke of something, do something at this invoke. And then we can just take in the object that is being used, right? Something here, that's the object that's being used, and then access the parameter. And then we can just return an integer that it would normally return. And then we can just do whatever we want here. So what we can do is we can do something that do something. We can just call it in here with x, and then we can just multiply it by 3 or something like that. So it will completely delete the previous method call, and it will just inject your injection with that object and that parameter. Pretty nice. So we'll see a concrete example, like a useful example here, semi-useful. In drop item, we have set velocity method, right? We've seen that one. Ordinal 1, so we are going to target specifically this set velocity method. And we've been messing around with this. So it is called on item entity, so that is our instance, item entity instance. Then it has an x, y, and z, of course, for the set velocity, so double x, double y, double z. Then we can also still use the parameters of the drop item method, so the item stack, the throw randomly, and the retain ownership can still be used. There is no locals here, so I cannot do any local captures. Bit of a shame. Local captures only works with inject, I do believe. So at redirects, you cannot use any locals. That's usually fine though. It's usually fine. And it kind of makes sense because you're now injecting like a separate method, right? So it makes sense here. Okay. Then what we want to do is we just print out drop item 8, and then we just do instance.setVelocity 0, 0. Right? So normally we do instance.setVelocity and then some really elaborate x, y, and z. We just gonna completely ignore these x, y, and z, and we're just going to inject 0, 0, 0. And that will just drop the items straight down again. We'll see that I have another example prepared here, and we'll see that in just a second. But we'll first do this one. Okay, so this will just drop items straight down. If I actually select the diamonds, that is. There we go. Just drop items straight down. It of course still has the delay and everything. That makes sense because we're only changing the set velocity. There you go. And just to show that it actually works the way that we would expect it to, you can enable this other line. And what we do here is we just plug in a normal x, y, and z. So if we just do the normal x, y, and z, nothing changes, right? We just call the exact same method. But then we just multiply x by 5. So the velocity in the x direction is just 5 times as large as it normally is. That will be weird. It will give us a pattern, like a throwing pattern, like so, right? If this is the x direction and that is the y direction, it will give us a really weird ellipse as a throwing circle. We'll see that in a second. Or that's what we expect, but yeah, that's definitely what's going to happen. I did, of course, test all of this beforehand. That is weird, huh? Coming prepared? Wow. Wow, wow, wow. Okay, here we go. Yeah, sorry for the delay. The internet is not really that great. I'm already really happy that I'm not dropping frames, especially when actually loading Minecraft. Okay, so now if I look into... Oh, that is F4, that is not what I want. Oh no, am I gonna record something with Shadow Play now? I don't think so. I think I'm fine. I don't have Shadow Play right now. Okay, great. That's a screenshot. I can't press F3, it's very hard. Okay, I'm sorry. Where can I see in what direction? Right, this is positive X. This should throw very far then. Poof, there we go. This is positive Z, should be normal. There we go. The negative X should throw very far again. And this is Z, should throw not that far, like normal. And this is like an in-between, which will just throw very hard in the X direction. And you'll see that if I just throw a bunch of these items, I'll get this really weird ellipse shape, right? F3, gone, U. There you go. Exactly what we expected. Let's pick everything up again, otherwise it's just a big mess. And then we'll get to the next example. 63 and 64. Why do you implement that? There's already a mod doing that. This is just examples for Mixins. It's just for a tutorial, man. Just examples. It's a complete, like, unusable... Well, it's not unusable code, but it's probably not very useful. I do agree. I guess Quark or so? I don't know. Does Quark give you a really weird throwing velocity for your items? I don't know, man. But it's fine. It's not a serious mod. I'm not releasing this mod. Just for the tutorial. Okay, so then example 9, return redirection. So we can also do this. Right, so we can redirect. Let's see. What are we actually doing here? The get job. This is the normal thing. Ah, right. So this is a redirection with an actual return value. Yeah. So example 9, return redirection. So what we do here is we actually redirect a method that has like a return value. Set velocity doesn't return anything, it's void. So it's not super interesting. If your method actually returns something like parentheses.getYa, which is, you know, the direction in which you're looking, then you just return a new value there, right? It's as simple as that. I don't think it's particularly useful to go over this, so in the sake of time, we'll just skip this. But it's the same as the other redirection. Exactly the same, only the method that you're redirecting has some sort of a return value, and therefore you also need to return it in your method. Just as here Fabric explains it, right? Perfect. Then we can also redirect get and set fields, and these are a little bit weird. So what we can do here is we can get a field, but instead of actually getting the field, we get something else. So it can show it best with this, right? With this visual example. So in this something class, in this foo method, we call this.aaa. What we then do is instead of returning this.aaa, we just interject some code with the method that we're calling on. So it's just this. And then we have to return something of the same type as AAA, which is of course an integer, and then that will just get injected into the code. So you just basically you can put in whatever you want in here, right? It's quite nice. Whenever this field is called AAA, you can just interject some code that maybe returns something else. Okay, so how do we implement that here? Whenever we get util.random, which happens a couple times right over here, for example, but also here when we throw randomly, but also for k. Normally in Minecraft, when you throw something, it gets like a little offset to the left and the right, and a little offset up and down, right? You get like a little bit of spread in where you throw items. What I do here is every time that we get our this.random, I just return a new random seeded to 0. So that will always return the exact same value. Right? Just a new random object with this, just a set seed will always return the same value for the next get float, or next float, I think it's called. Yeah, next float. So let's see this. Do our items now end up at exactly the same position every single time? We'll see that it's of course a yes. In the get field, of course, you get the instance that we're calling on, so you don't need to get the player entity yourself. You get it in your parameters. Quite nice. And then, of course, just the parameters from the drop item method. You can also access those in here. Great. But again, it's not an inject, so you don't get any locals, so you don't get any captures. Unfortunate, but it's doable. We can manage. Okay, let's make this a little bit bigger. And then in here, we can just throw items. And you'll see that they all end up at like exactly the same position with basically exactly the same trajectory. See that? It's pretty nice. That is pretty nice. I could show you all what it normally looks like. So if we don't have this redirect, just in the vanilla Minecraft case, just to compare, right? We'll see that it has this little bit of spread. Okay, so if we now throw items, you'll see that they get like a little bit of a shift up. And now you saw that that one went a little bit farther up than the rest. That one just went a little bit to the left. Let's see if we get another one. This one also went a little bit farther to the left. This one went a bit to the right. This one went a bit up. It's subtle. It's subtle, but it's there. But of course, if we interject with a new random, set it to 0, that's no longer there. So if you want to get rid of random item throwing, then that is the way to go, basically. You can, of course, also just interject with this next float and then just return 0 every single time. Which would make more sense, let's be real. That makes a little bit more sense. But there are definitely useful cases where some methods call some member variable that it just uses that, and it's not quite what you want, and you can interject there. Always use the easiest way to solve these issues, so if this happens to be the easiest way with the least modifications to the code, then definitely do that. Let's move on. So we can also, of course, interject at setting a field. Now I have to do some weird stuff here because inside of our drop item method, we never actually set the field. So I went to this tick new AI method, which is also a player entity. And here it sets the head yaw. So the position in which the head of the player model is actually looking. We can interject at this set position here. And instead of setting it to this.getYaw, we are just increasing head yaw by 2.0f. And you can see again here in the put field, it just completely removes this.aa or this.headYaw equals line. It just completely removes that. And it just interjects a new line with this and then whatever was the old value that used to be set there, but now isn't. And you can choose to modify this original yaw or to not do anything at all. You can just completely remove it. So you can just do this and then head yaw is not updated at all, which can also be quite useful. Honestly, that might be the most useful thing here. Or you just update it with whatever value you want. So in this case, I update it with 2.0f every single time that this is called. And you will see, this is in degrees by the way. Not in radians, what I first thought. And you'll see that this looks slightly disturbing. If I just increase the head yaw every single tick, this is of course a tick new AI function, so this happens like 20 times per second. This will get called 20 times per second. So yeah, we just increase our head rotation with 2 degrees every single tick. Yeah, it looks great. It looks great. Actually, here. Oh, you're already starting. We aren't in the world yet. Okay, come on. Yeah, there we go. There we go. Hi, guys. Hi. So that totally works. I can still look down, as you see. It's really weird if you look down like this. Yeah. It looks very, very weird, but yeah. So we are now the exorcist, basically. Pretty great, or an owl, whatever. You can make an owl mod like this. Pretty cool. You totally could make an owl mod like this. You can turn your player character into an owl. Okay, then we can modify an argument. So that is pretty cool as well. So let's go here. We can modify an argument. So let's say that we call a method something to do something. And we have a true, 1, 4, and 5. And maybe we don't want actually to insert a 4 here, but there is no real other way for us to change the 4. Or maybe we want to... This is such a bad example. Honestly, this is such a bad example. Let's imagine that we have like some sort of a function, right? We have some sort of a foo function. Then we have like an object here, which is like a class object obj. Very cool. But then we want to do something, so we have like the to do something method here. And normally it takes in this obj, but well, that's probably, we don't really want it to use obj. We want to put in something else here. We want another object in here, or at least we want to change something about obj, but later we do something else. So do other thing with obj, and we want to keep that intact. So we can't just change obj here, because then both methods get affected, right? Then it changes here and here, and we don't want that. So we can interject right at this position, and then we can change obj. So in that way, it is quite useful. We don't really use it in that much of a useful way though. So in set velocity, we will change the x. Also the index is of course the index of the argument that we want to change, which is 0. At invoke, at set velocity in our provider method again. Like that all makes sense, right? So we can use index 0 here, and that just means that if we go to drop item and then to set velocity, it will only affect the index 0 argument, which is in this case the x of set velocity. So we just take in double x and we export some other x, which is in this case 0. If we run this, we should see that it behaves just fine in the up, down, y direction and in the z direction. But if we throw an item in the x direction, it will just drop down. Very, all right, so you soon debunked. Well, so if we are looking in the z direction, everything should behave just fine, as you will see. Now we're looking in the x direction and plop, 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 plop. Like it does drop up just a little bit, especially if we look up. See, so y works fine, and then it just goes down. Okay, next up is example 13 with modifying multiple arguments. You can, instead of ModifyArg, you can use ModifyArg's. Oh, I suppose I didn't really mention that it is a different add. It's ModifyArg for modify arguments. Makes sense, right? You can also modify arguments, which is a multiple, which means that we just modify all of the arguments of set velocity. Here, of course, at invoke at set velocity from our drop item. We no longer need the index then. It doesn't even define an index anymore, which makes sense because we are not only modifying one argument, we're modifying all of them. This is probably the most useful one of the two. You can also just use the item stack, throw anomaly, and retain ownership that we get from the method by default, like normal parameters. Then we can use args, which is a special object, and we can just set the index 0 to value 0, index 1 to value 0, and index 2 to value 0. If you have a method with 5 parameters, then you can set all 5 in index 0, 1, 2, 3, 4. If you have a method with 3 like this, but you really don't want to touch the y, or you really don't want to touch the z, or really don't want to touch the x, let's not touch the x in this case, then you just don't do anything here, and it will just behave as normally. You can also set it to args.get index 0 and then just multiply it by 2, for example. I mean, that is totally fine. This is an object. I have to cast it to a double first. Should be okay. There we go. So let's run this one. And then in the y and z direction, our item shouldn't have any velocity, and in the x direction, it should have double velocity. So it should go pretty far in the x direction and nowhere anywhere else. Right, that is exactly what we would expect. It's a drop item 13, so we should see that printed out here, but I mean, we have come to expect that it happens now. That it happens as expected. Okay, let's load up this world. Then in the direction that we're already looking, this should be the x direction, right? We were just looking at the x direction, so I can throw here, and that throws pretty far. It's a little laggy, let's try that again. Bloop, pretty far. And in the z direction, it just drops straight down. I can just show that here. So it's quite a nice change here. Can be quite useful. Of course, this just means that the arguments are already set to their default as they are used in here, and then you can just change them by setting them or getting them, or you just don't do anything at all, and then it's already set to what is set to by default. Pretty useful, actually. Actually pretty useful. Because then, again, in the example where you do actually have an object and not just some literal, you can change this object without actually changing the original object, and therefore you can only affect this method call, but not the rest of the entire method. And that can be great. Okay, next one, we have parameter modification. Just like arguments, we can also change the parameters in our own method. So in drop item, we can add modify variable in our own drop item method. In the head, of course, because it's in the parameter, so it should be all the way at the top. And then we can change item stack. And then this really doesn't make any sense. Normally you would use just this. Item stack, that is then the parameter that you want to change. Ordinal 0, so it's the first time that you encounter it. In our case, it doesn't really matter. And an item stack again as a return value, and then you can just do whatever you want to item stack. Funnily enough, you can just take in the parameters as well, your method parameters like normally. So you take in your method parameter, but then you also take in your other method parameters. It's really weird why that is even possible. It doesn't really make any sense, but it is. So right now we're taking in this item stack, and then we are just not doing anything with it. We are just going to return an item stack of 8 beefs. And that means that every time we press Q, we should just spit out 8 beefs, like we normally would, like in a normal throw pattern, but 8 beefs, even though we throw diamonds. So let's say that you have some item that you need like blow dry or something, then by throwing it out of your inventory, it like automatically like converts into this new item and some sort of recipe. That's like a useful case to use this for. You just need to put in a check here. If the item stack of get item is your modded item, then spit out this new item stack with this new item, the recipe. Otherwise, just spit out the normal item as usual. Okay, so this is just going to queue, and that's just beefs, 8 beefs. So this is 4 times 8 beefs, which is 32. Oh, forgot one. There we go. There you go. No more diamonds, 32 beef though. Pretty good trade. You can, I don't think I have actually an example of this. I don't think I have, okay. You can of course do the same thing here, but instead with a boolean, which is like throw randomly. I can't do the exact same name here, and then I also have to return a boolean there. And we can just return true, for example. That means if throw randomly is always true, we always go through this path and we just throw completely randomly. It does mean that I can use ordinal. If I use ordinal 1, it will take in the second boolean, which is the retain ownership. So now retain ownership is always true. If I put it to ordinal 0, it's the throw randomly is always true. So we can test this. But you'll see that this works as expected. So there we go. We have some more beefs here. Don't really know why. And then we can throw our item, and you'll see that we just throw it in a random direction. Because we throw it randomly now. Pretty nice. That is pretty cool. Aha. Next to parameter modification, we can also modify a variable. So what we can do here is at a certain store, we can change something. And you'll see that this one behaves very weird as well. So at modify variable in our drop item method, right? At store ordinal 0, we will modify the set of this local variable, item entity. So we can just write the signature as you would expect. So the item entity to be returned, and then the item entity that is taken in, like which is this guy, right? The original, taken in as a parameter. We can return whatever we want. Then we can also just take in the parameters of the method, just like we would expect from all of these other examples. Now, so what we do here also is completely as you would expect with all of these other examples, is if we go to modifying a variable assignment, it just removes the original line and then it just sets whatever variable you want to change to whatever you do in your code, taking in the original value that you were going to set. This has a bunch of weird things, expected player entity, like weird errors. Not really sure why, because if we run this, it just works. Oh, by the way, what we do is we just set the position of our item entity that we spawn in to 2 times or our y position plus 2. So it will spawn above our head. For the rest, everything is still the same, right? So normally with the item entity that we created, we spawn it at our eye level, minus just a little bit. It has to be at our mouth and our eye level, right? And then now we just add 2 to it, so it will spawn above our head. And you'll see that it just works. Even though it says that it has errors, it just works. So why? I don't know. Mixins are really weird sometimes. So if we do F or F5, spawns above our head. Nice. Exactly as we expect. Awesome. There we go. Then we also have, with ordinals, the same thing, but if you have some float f, you can use ordinals to go through different instances of floats. So here it can only infer that we are going to change a float, but which one we don't really know. Normally we just get the first one, or you get every single one. If you don't do this, you do every single one. Otherwise, ordinal 0 is the first one that you find in the method, which is this f. This f really isn't used for anything in here for some reason. F is set, but in this item.setVelocity, f isn't actually used. So that doesn't really do anything if we set ordinal to 0. Even if we just return -2f, we just disregard everything else. Doesn't really do anything. If we set ordinal to 1 though, we're going to find this g, and g affects, let me see here, it affects the y level at which we spawn our item. -g times 0.3 plus and then some random value, right? So if we go to our return value and we see it's -2, we will get -2, which is +2, times 0.3, which is 0.6 plus some random offset. So we will get a pretty significant plus y velocity to all of our item drops in this way. if we use ordinal equals 1. So we can check this, see if this works. Again, you can take in the parameters of the method, stack, throw randomly, retain ownership. Just like in everything else. Asterisk. It doesn't actually work with everything. Sometimes it will just crash, and then if you remove them, it doesn't crash anymore. And why? It really doesn't say. It doesn't even make any sense. Like we just showed here a couple ago. I think it was here, right? We were changing the item stack. Oh yeah, it wasn't this one. Originally we had item stack, and then again we take in our parameters while changing our parameters. It really doesn't make any sense, yet it works. And then in other cases, you think it should work and it just really doesn't. Very strange. Anyway, if we throw right now, you can see that yes, we do in fact get very high velocities. So that totally works. This is of course then with ordinals. So we now specifically target the G. So not index 0, but index 1 of all of the float parameters here in this method. You can see that before here there are no floats, there's only a double. So that's why that works. Okay. Pretty cool. Then we can also modify constants, which is now again a new add ModifyConstant in drop item. And really a constant, I think that's a bad name because it's just like some sort of final field that you have inside of your class. That's not what it is. It's really more about literals. That's why I have literals in here. So you can have methods in drop item, of course, just like always. And then the constant, now we have to target the constant at double value and then this specific value. So we are going to change the first constant that we find that has this specific value, which is of course exactly here in the calculation of D, which is the height at which the item spawns. So if we then set that to -2, so we get this at I, y -2, we again spawn the item far above our heads. And that's exactly what we do here. Again, you take in the double that you would normally place there, which is always 0.300 because you specifically target this literal. So I don't really know why you would need that as a parameter. You already know exactly what it's going to be in every single case. Weird, but it's there. So you can actually just access double D, which is the original value. And then you can also access the item stack. Randomly retain ownership, you know, the parameters. Okay, F5. Then we can Q and boop, it spawns above our heads as expected. You can of course do so much stuff in here. I think modifying literals is actually extremely useful. As opposed to some of these others. Literals, you see these like everywhere. Let's say you don't want a random value between 0 and 2 pi, but you just, instead of going in the full circle around you, you want this behavior to only work for the semi, like the half circle around you. Just changing this to 1 pi. Very useful, actually. Very, very useful. To just very discreetly change behavior. Oh, that just did something weird again. To very discreetly change behavior without really affecting anything else. This one is super, super safe in that regard. Because it doesn't change anything else except for some literal. And no one's really going to conflict with that, right? So it's actually pretty great. If you can use ModifyConstant, absolutely do that. Instead of anything else. Then we have the nuclear option. However, on the other side, we have the nuclear option. On the one corner, we have something super safe, constant literal modification. And then in the other corner, we have the nuclear option overwrite. Example 18 overwrite. Guys, you can just write at overwrite, not overwrite like normally, right? But at overwrite. You can then place here the exact same signature of the method that you want to overwrite in your targeted class. So the exact same signature as this one. It's exactly the same thing. Even the name, I think I can change the name. No, you cannot change the name even. It has to be the exact same thing. This will just delete. Oh, I got rid of my my Explorer. This will just delete this entire method and just inject your method there. This is bad. If you can, if you can avoid doing this, please do. So what happens here is any other modifications made to the player class will probably fail this way. You'll see if I like do this add constant, I'm targeting this constant, but that constant really isn't here anymore, right? Because I just completely deleted this whole method and then I just pasted in something completely different. So this constant isn't here anymore. That's for sure. Like a lot of these method calls that we were like overwriting and targeting and injecting next to, it just doesn't exist anymore. So all of those will fail and you'll get a bunch of errors. So really only use overwrite if you absolutely do not have any other options. That being said, in overwrite, you can just get your player instance, right? Just like we used in the beginning here of this tutorial, and you can write something. This is actually 18, not 17. Whoops, my bad. And then in this case, we're just going to place a new item entity in the world at x, y plus 2. So above our heads, z, and then x, 512 of them even. Yeah, you can go truly wild here. It offers you amazing flexibility to basically do whatever you want. But it will come at a great cost that it will not be compatible with any other injection or just mixin in general at this specified method. And that will probably crash with some other mods. Probably not be compatible with some other mods in that case. Also, worth noting is that the Mixin tutorial ends after the constant. There is no overwrite example, so you're welcome. Yeah, that is something I had to find out myself, that was something that was possible. It isn't actually explained anywhere in the documentation. So, if we have 5, we should spawn X above our head. There we go. We spawn X above our head without any real speed. Suppose they do have a little bit of an offset. A bit of a random offset there. I suppose that's normal, if you just create a new item entity. Makes sense. 512 of them, so actually that is like a lot. So if we do this, we get like 8 stacks. Yeah, there you go. Stacks of X also, not really something that you can normally do, right, with X. You can kind of cheat there a little bit. Which is pretty great. It can be great. I also noticed that I kind of just have to comment out the entire thing, otherwise it just will not work. Or it will still conflict. So it's a bit weird, probably because of the naming. Here I did something else. Oh yeah, the shadowing. That is the last example that we really have here. Let's get rid of all of these comments. There we go. So, if we have our item, right? Or we have our overwrite here. And it doesn't have to be an overwrite. This can just be a normal inject at the head or a tail or whatever. And we want to access some private methods. So we just get our player entity player equals player entity, we'll take this, right? Nice. Then we want to access player that spawn particles because we want to spawn some particles. Pretty cool. Doesn't work. Why? Has private access. Oh, right. This is a private method. So we cannot actually access that from here. Really annoying. What we can do instead is we can call this dot spawn particles, and this will just create, if you just do this dot spawn particles, it will just create this shadow here. And that is why the whole thing has to be abstract, because of course this method has to be abstract, otherwise Java will not compile. Like this will not compile because it doesn't have a definition. There we go. So then your class has to be abstract as well. That's where that abstract came from. And this shadow particles, shadow spawn particles, will just kind of be a placeholder for the actual method, and you can just use it here, and on compilation it will get rid of this. It will place the spawn particles inside the player class, then private will be accepted, right? Because you're now part of player, so you can now access the private spawn particles. And then you can call these methods. Yeah, it's... Oh, this should definitely be 19 actually. Not great, maybe? But if you really need to access some of the private methods of a class that you are mixing into, this is basically the way to do it. Right, so you use these shadows. I'm just using overwrite here as an example, but again, you can just inject in the head or the tail or add some method, or you can use it as some invoke, right? You can do it as some redirect or some modify variable. You can do it with anything. If you need to access a private method of the class that you are currently mixing into, you can use these shadows. Really, 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 really useful. In Minecraft specifically, I think a lot of methods that you would want to use are already public, so you should already be able to use them. But there are a couple of exceptions, and that is where this shadowing comes in. So now we can go and see that we actually spawn particles. Spoiler alert, we don't, because as you will see, drop item 19 will also only be called once, and that is because this is only called on the server. Play.client is always false. Drop item is only called on the server side, and so, well, I can spawn particles on the server side, but that's not really going to do anything now, is it? Yeah, the client is not going to render those things. So, yeah, that's kind of a shame. Kind of a shame. Doesn't actually work. There was no other private methods in the player class that was actually anywhere close to being useful. This was the closest I could get, but they couldn't actually use it. So that's a bit of a shame. Like, I can queue some items here. That's not really going to do anything. I'm going to get some eggs, of course, because I have this line here where I do the same thing, but I only spawn one egg. Yeah, but no particles. You can also see drop items only called once for every queue that I do. See, so the other code is not even called. It's a bit of a shame, but yeah, that's how that works. Well, with that all being said, I have this one example that I still need to show you, and it is not actually in here. We have to go over to the World's Chunk Mixin, which is actually a real-life mixin that I wrote for the Not Enough Lights mod. Let's go here to go down to the load packet. So I redirect here a method call invoke from the load packet, and the target is consumer.accept. You'll notice something about this accept though. Let's go to the load packet method and we'll see. So I'm targeting this method and I'm redirecting this method, which means that I take in this thing and then I basically just get rid of this entire line. I take in the consumer, I take in this parameter that I normally put in, and then I can do with it whatever I want. I could also take in this argument and then change that. Also very possible. Could have done that. Didn't do that though. Don't know why. Don't ask me. Problem is, accept actually takes in a generic, and consumer is actually a generic object. Right? Consumer here is a consumer block entity visitor. Well, very annoying, because how do we use generics actually? Wow, generics. Yeah, Minecraft uses them a lot, so this is actually very useful to know how to use them. What we can do is we can just get the targeted object, right? The instance object, consumer. We can just not specify any generics here. It will complain about this. It will give you a warning, raw use of parameterized class consumer. It's fine though, this works. You just have to be very, very careful that you use consumer only in the context of a consumer block entity visitor. You can even cast it to that, but I don't think if I use this and then block entity consumer. Why does that not work? Oh, it's visitor. Whoops. Block entity visitor. That also works. Okay, so we can totally do that. We can totally do that. We probably should then. So we can take in consumer with this generic. Then the parameter that we get, which is the generic, we can just take that in as an object. Can we use now the block entity visitor? Yeah, we can't. So it isn't smart enough to detect that this object will always therefore be a chunk data.block entity visitor. We can just use objects though. We can just take in an object as the generic, and then the packet bypass and the MBT compound, that is just, I'll show you here, this is just the parameters of the method, right? So I can just take those in. I can also just take in another one of these guys. I could. Still a bit weird though. Don't really need the second one of those. Yeah, it's weird how you can do that. Anyway, then I can use this guy in whichever way I want. Then I can cast it to the specific generic that I want. Of course, I don't necessarily need to do that anymore now that I've already specified it with the generic that I want. Then I can accept the block entity visitor, which is a block entity visitor, and that will do just fine. I can also use this object, obj, and then I can cast it to a block entity visitor, and that will also work, right? I can do this, that, then I can use obj here, then I have to cast it to a block entity visitor, and this will then work. And then I can just use this obj as a block entity visitor, and the generic just works. There was no documentation on any of this online. I had to kind of figure this one out through trial and error. That's why this one, I guess I could have done that slightly better. This is how generics work. Just use objects for the generic types. And that does the trick, basically. In the targeting, actually, I had to write this one out manually. A lot of work, kind of annoying. How you write it out then is you just get your Java util function consumer, you know, which is the object that is calling, then method accept, and then as the parameter, again, you take in the object. You take in a object, and that works. And then you have to put in an object there. That does the trick. Then it can find that method, and then it can invoke your redirect. Yeah, that was fun to figure that one out. It's fun to figure that one out for sure. Anyway, this is also not all no documentation, so yeah, I also don't even have this in my handy dandy example class because player entity doesn't really use any generics, so I couldn't really find anything too useful where I could test this on in any examples. Anyway, I really have to get going now, so this will be the end of the stream, also be the end of the video. If you liked this video, please leave that like, please subscribe for more Minecraft modding content. Really, I'm really enjoying this sort of stuff. More tutorials definitely on their way. And go to the Twitch channel, man. Go down below. Strike a little link there to the Twitch channel. It's a lot of fun over here. When the internet was working, that is. And then hope to see you there. Well, good luck programming, everyone. Good luck modding Minecraft. See you all later. Bye-bye.